Now, I would like to welcome Dr. B.K. Tyagi Sir, consultant, AWSAR program, to give a talk on understanding of popular science writing.
Oh,
वेलकम सर सर अनम्यूट कर लीजिए
Good morning to all and to all my friends and our director, Dr. Nakul Parishar sir. I think a very the tone has been set by our director sir, and I'll take you to the idea of what science communication is, why it is necessary, and why we are asking why this program has been initiated. In fact, it is a you can say it's not only a competition, but it's an approach, or it's just a method by which we are trying to induct our researchers to science communication. That means like we are trying to inculcate that skill of articulating your research to the common man so that they can understand that. So through my presentation, will go to a journey where which I have divided, like what science communication is, why it is necessary, why we are asking you to be part of this fraternity of science communicator by sharing your science to the people, and also take that participate in that competition, just to not only win the award but also the laurel across the country. So I'll start my screen sharing, and so my screen is visible. Vyoma, can you just let me know that?
yes sir
Okay. So now if we look at the way the things are changing in last 30 years, the entire world is at our fingertip, and we have become a global village now. The speed has no meaning. The transfer of message is instant, and we are becoming a knowledge based society. Means whatever the new knowledge you are developing, it is necessary, it may be converted into a product, into a technology. And that means, suppose the people on down the line, like the political our politicians, our policymakers, our industrialists, and the general public, they should know what is going on in our labs. And also to that, to reach to those people, to our legislators, industrialists, media, and the general public, it is the communication which is the key to carry the benefit of scientific knowledge. And not only that, the our standing in the world will depend now on our ability to use scientific knowledge and the level of scientific thinking, what we call the scientific temperament or scientific approach in adopting more and more that scientific approach in our day-to-day life, which is also the constitutional mandate, as has been enshrined in Article 15AH of our Constitution. So this is you can say the basic premise why we are trying to induct our researchers into the field of science communication. Because not only that, because if we look at scientists is as a community, they don't communicate the science. This is a, and if I remember, there's only the three names of top scientists: Dr. Rajent Narlikar, Professor Yashpal, and Dr. Abdul Kalam sir. These are the only three names who has excelled in their own field, as well as when it comes to taking science or communicating science to the people. These are the three names. So we want more such: Professor Yashpal, Dr. Kalam, Dr. Jayant Narlikar, uh, because why it's now, as I told you, this in change scenario, why it becomes so important. So what science communication is, in first we try to understand that. So science communication today, if we look at it, it's an area of activity, research, policy that refer to public communication, presenting science-related topic to non-experts using different means, modes, and media. That means I have to write in such a way that a person, if he is not from my field, he can understand about my research. First thing, and not only that, even in science also now science, the research or the outcome of science has become so specialized that even among the scientific community as a whole, a person from the life science field or from a physics or the chemistry field may not be able to understand what is being done in case of the medical science or the other science. So for that also, for that development also, for that research also, he is also a layman. So he is not a PS for them, but he is also a layman. So how a engineer can appreciate the research of which is being done in the medical field, because he is interested in that as a human being, but because of his training, different discipline, he may not be familiar with the terms and terminology which are prevalent in medical science. So science communication, again, the other definition is being a complex network of social channels, serve as a mechanism of bridging the gap between the scientific community and the lay public. So that means what, in how and why, and the way it can be communicated to the common man. So to bridge that gap, and why it is necessary to bridge the gap, because we are nowadays, we are living in a democratic country, and the most of the funding for research is coming from the public money. So public has a right to know what is going on, how their money is being utilized, and what kind of research is being done. So now, as our director, Dr. Nakul Parisha has just referred about the scientist's social responsibility, it is mandatory on their part that they should tell the people whose money they are being used in for the research, that this is the thing they are doing. So this AWSAR is also giving you one opportunity to our all researchers to talk about their research to the common man. And also, this is again, if you theoretically, if I will go back around in 1950, where this theory of two culture, the scientific culture and the other culture, and there is a gap between the, as the first definition is saying, it is a process by which the scientific culture and its knowledge are incorporated into the common culture. So that means it is in a way, for general understanding, it is like uh, conveying the complex scientific idea into a simplistic form, but without diluting the scientific content or the scientific aspect of that. And the most accepted definition is by, because this is an empirical definition which has been given, because now this science communication itself is an area of research also. There are many universities which are offering that the course, PhD course, and the master degree, diploma, certificate course in science communication. So so more and more, because literature is still coming up in a way, more and more definition, concepts, and new idea which are being coming out in a specialized journal of science communication. So this is the most definition, which is that the science communication is the use of appropriate skill, media, activity, and a dialogue to produce one or the more of the personal response about science in among the people, which may be a awareness, means you're informing, creating an awareness, enjoyment like our Science City and Science Park, then creating interest in science, opinion forming and understanding. Like when you're talking about GMO crop, that means this, when you are communicating about the GMO crops or the GMO process itself, genetic engineering also, that means you are conveying, or the purpose is to form an opinion about that and the understanding part. So and the purpose of that, the science communication, the very purpose of science communication is to make people aware of scientific and technological development, to enhance the level of science and technology literacy. So because, as I told you in the beginning, that our standing in the world will be decided by the ability of our people to understand at least the minimum science and technology, so that which will be reflected in all aspects of their life, in their social and individual behavior as well, and to enable them to take an informed and rational decision making and strengthen their decision making ability. Because look at this scenario in the context of recent pandemic of corona, uh, how the people behave, because the virus which is not seen by naked eyes, and the people who don't have information, the situation was not only India but across the world, where the social norm or the guideline which were given by issued by the authorities, they were defied by the people, and they say they will not follow that because it curtailed their liberty. So, and without, and this was the here, the understanding part was missing about the science or about the corona itself, and to develop scientific and technological temperament in them, which would reflect on their systematic and rational behavior and conduct in the society. Because you might have seen, if there was a proper understanding of about the vaccination or about this corona, the people would not have refused of the vaccination because of that, and that they have not followed those social norms, and also they fall on myth and superstition rather than taking post to the science. So so now if we look at it, the importance of science communication, because science communication, the terminology itself has because this is a you can say a method or approach which has evolved simultaneously in different part of the world for different region, and that's why the nomenclature is different. In India, we call it a science popularization or Vigyan Lokpriyakaran or science communication. But this is the term in the Western world or the European world is public understanding of science and technology, or public engagement of science and technology, public understanding of science, etc., etc. Because of the our policy document of 2013 and the recent draft policy has also, the word which they have used is public understanding of science and technology. So here now the science communication itself has a social dimension, because if this information gap was not there in the society, I think we would have more responsible behavior of people during the corona pandemic. And it has a economic aspect also, because now if you slightly go back to the speeches of our Prime Minister, Mr. Narendra Modi, he said like we have to achieve a target of a $5 trillion dollar economy, and the engine for that achieving that target is science and technology and innovation. So this is a like any country who has to be developed economically, that means that science, technology, and innovation is must for that. That will be the basic for foundation on which this economy will be built up. And that's why like what is the science and technology is being done in our laboratory, it should be known to the industrialist also, to the policy maker also, and to the media also, to take it to the specified target group. Because it is interesting, I read somewhere like because most of the research which is being done across the world, it remain confined to certain technical paper which are written for publication as a part of PhD process, and it remained the circulation remained very limited, and that information, that knowledge is never come out for its potential use or for its potential application. So somewhere it was written like the China is using those basic science which has been published across the world and trying to convert them into different product and technologies. This is I don't know to what extent this is true, but I read it somewhere. So then it has a political dimension also. So now science communication, you can see to even in India itself, the vaccination, there was a reluctance on certain community in India itself in the name of a religion, and the certain political parties have also uh, you know attributed the development of vaccine to a particular political party and refused to take that vaccination. So that means a scientific issue can convert it into a political issue also, and as well as it is a diplomatic aspect also there, because you can remember, you can I mean, this memory is still very fresh in our mind when we provided the vaccine to our neighboring country for that, so which help us to have more cordial and friendly relations with those countries. So now you can see the importance of science communication, and also the importance of science communication, or the has been also as a mandate. It has been given our in constitution, as I told you, article 15AH. And then education policy is also talking about like the developing the problem solving skill, problem identification, and scientific temperament, development of scientific temperament among the students. And science technology policy of 2013 is also talking about the public understanding of science and technology, and same is with the draft policy, which is yet to be come out as a policy, and the intellectual property right policy also, because this IPR issue is becoming more and more important around the world. So for that also we need that minimum basic understanding of science and technology. And for a realization of the sustainable development goal, to ensure the participation of people in achieving those goals, it is mandatory that those people should also have the understanding of that minimum science. And Child Right Convention in Article I think 12 of that convention, it is also talking about the understanding of science, so that the child can exercise their right in a more proper way. And these are the four national bodies which are totally dedicated for the science communication purpose. And if you look at this, the science, technology, and innovation policy of 2013, the word has been used, the public sector, public understanding of science is an important dimension for introducing and reaching the benefit of modern science and technology to the people. So that means even in the policies also talking about and in a way asking the scholars, the researchers to communicate about their science to the common man, to the people. And these are the prevalent method or approaches which are being used for taking science to the people, like through the print media, newspaper, magazines, etc. Then the electronic media like television or this cable network, etc. Then now it's more important is social media. But social media has a slightly more disadvantage. You don't have scope to verify or to attribute that the source of information to to one person. So we have to take it with caution, that information which is coming, and sometimes it is doing more harm than benefiting it, because of there was a lot of cases of black fungus in India. Around 49,000 were reported somewhere. I read it. And the one reason was like about this, the information which was spread through the social media, the entire protocol was given on that of your medication in case you have a fever more than 3 to 4 days. So you take this medicine, this medicine, this medicine, and few of those medicine were having, steroid as a content in them. And as we know, this is a general information, when the steroid, increase the blood sugar level. So if you are not monitoring your blood sugar level and you keep on taking those steroid, that means your sugar level will goes very high. And if you are in, you already have a morbidity, I think you have a very good chance of having infection of this secondary infection of this black fungus. So this was one of the case. So information was given about the medicines, but not the what you don't have to do or what precaution you have to take. You have to check, you have to keep under control your sugar level. This was not mentioned, and so this information turn out to be a disaster. So that's why we have to be very, very careful when we are talking about this. And the interactive communication, the way I'm talking to you, this is an interactive way of like delivering lectures, addressing large gathering, etc., and the folk media. So our traditional folk form are very rich, and we have been using traditional folk media also for science communication. But here under AWSAR, the competition is only for the print media. Means like you have to write your story in 2,500 word. That is the maximum limit to convey your research, what you are doing, and how it is going to benefit the society. Okay. So now let's try to understand that the what research is, because many times we have seen, I have observed, like when the stories are coming to us for evaluation, we found that except writing the corrects of your research or the methodology, the literature survey which has been done, all is there, but the actual research component is missing. So people are not interested in knowing your methodology, your literature, what you have done, because you are not writing or you are not doing it for your peers. It is for the common man who is interested only in the outcome of the research. So what is research? Research is to develop, to generate or develop a new knowledge. That means something new which has not been done earlier. Once we get registered for our PhD, for 6 months we are doing only the literature survey to find out that gap which has not been done, and that 0 point is the beginning of my research, where that means whatever I'm starting from zero, I'm creating something new which is not known earlier, and it may be a pure research or an applied research or experimental or field-based survey. And pure and experimental research mainly for academic interest and hold the potential to review or to relook at our existing understanding. It may change. Like one very interesting example is the finding of some dinosaur's egg in Gujarat. It turned out to be that when the entire thing was reconstructed by paleogeologists, it was found that India has a parallel dinosaurs to T-Rex. It was so huge, also carnivorous, like you might have seen the Jurassic Park, that film. The T-Rex was the most ferocious living creature in that period. So it was turned out that finding of those eggs turned out to be that India was also the place for the dinosaurs, and the name was given to that dinosaurs was Rajasaurus. So it was an Indian T-Rex almost named as Rajasaurus. And also now look at when once something, some experimental thing has been done, there also at that time, if you look at the research of the research paper of Einstein in 1905, it was for which the Nobel Prize was given. It was a photoelectric effect. At that time, it was part of a basic research, but later on, it was found that it found many application, and a lot of technology based on that basic research is now we are using. One of them is the remote system which we are using. And now this survey and experimental example of, I'll give you the traditional knowledge system, which is in practice but not validated empirically. So that will, through experiment, what hypothesis you have taken, you are trying to prove or disapprove. So this, now the question is, whatever the new knowledge you have generated and what will be its utility, what will be its future potential, I think that is the aspect which you have to highlight as so this is like you have to begin once you are start writing about your research for the common man. Just forget, like, you are not writing for your peers who is equally aware, who equally understand all the terminology which you use in your paper. That means you are telling to a person who have no idea. So this is like the data. All your research is data. They has to be sorted out. They have to be arranged for giving a meaning. Then you have to present them visually and then explain them with a story. So if you keep this in mind, to comprehending, to coming out, or to developing an interesting story will be easy for you. So
Slide sharing has been stopped.
there was share, resume share. It has come.
Yes, sir.
Okay. So before you start writing about your research in a popular format, the word is writing about your research in a popular format means which could be comprehensible to a common man who is may or may not have a science background. We presume like the up to 10th standard, if we look at the CBSE book up to 10th standard, it is a part of scientific literacy. It is not an academic science, but once you reach to 11th and 12th class, then the academic science is taught in those classes. But up to 10th standard, it is only a popular science or just to as a part of scientific literacy. So those terminology which are being used in 10th up to the 10th class standard, you can take it as like people can understand that terminology in your story. So what new will add my research to the existing knowledge? First, think about that. Something not known earlier, because then only it will have a news value in terms of academic knowledge, method, product, protocol, etc. So you will start from that. First, you zero down to that. And then what do the finding will imply? And how do the finding impact society or the environment or bridging the gap between science and society? For example, like there was one research which was done, I think, in some IIT, where they came out with a device where in a non-invasive device where the level of bilirubin, like because a child, especially the male child, when it's born, they generally get infected by the jaundice, and every time you have to puncture their finger to take out the blood sample. So suppose if we come out with some other method by which we can test that, the bilirubin test we can do without that invasive method. So that means it will help those newborn child, doctor fraternity, and also we also feel that this is a less painful and better than the earlier one. And what result drove you to the conclusion? That means your research methodology approach, what you have done, and why you do think the results are relevant to the society, and how did you arrive at those results, and how expensive economical are the procedure method as compared to the earlier one. So, and how difficult easy were the procedures. So these are some of the things by which taking into consideration you can make your story interesting. And you can start with a quote, undermine the obvious thing, because most of the time what happened, like the stories build up in such a way where the secondary data are being used and maximum space is used in developing the story by using the secondary data. So that means try to build up the start your story with your own findings and science as a tool for myth busting. Remind people of their childhood, something, some connect they should have with this. Use the story of some celebrity character or incident, because this is just one example which is coming to you. Myasthenia is a disease or a disorder of the body, old age problem, or autoimmune disorder, you can say, where you cannot indulge, so that medicine is there, so you have to take before you have to eat something or drink something. And Amitabh Bachchan is suffering from this disorder since last, I think, 25 years. But he is the one person who is suffering from that, but he is the best voice in our film industry. So this kind of connect will generate, immediate interest among the people, so that you don't have to create interest, but you have to sustain that interest. That's why, like, science writing is not only a skill, but it is an art also. So art and skill is acquired slowly over the time, but this art is also, you can sharpen that thing and call for action, participation, if your research is a field-based research, to be specific and be concise. These are some of and one example of uh, uh, because you might know this poet, great poet Ghalib Sahab, uh, but he was not popular during his tenure because he used to write very complicated poetry. Nowadays, because of the general awareness and uh, 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 being taught in school, colleges also, with their meaning. So we understand that. But at that time, when originally he was writing and presenting it before the people were not able to appreciate it. And the reason was one share of Ghalib Saab. I'm just giving you how he used to write and what the connect was missing, interconnection was missing, which people were, because of that, people were not able to comprehend. So one share of Ghalib Saab, we say, Magaz ko baag mein jaane na dijo. Don't allow honeybee to enter into the garden. Okay, so this is the first stanza. Magaz ko baag mein jaane na dijo. Don't allow honeybee to go into the garden. क्या के नाहक खून परवानों का होगा. Unnecessary, it will be the cause of the death of those insects. So when you burn a candle, there are a lot of insects, which is called parwana, parwane. वो उसके आसपास आ जाते हैं and they get burned and killed. So now the people used to bit confused. What is the connection of honeybees going to the garden and the killing of those insect parwana? So, but now we can understand that if the honeybee will go to the garden, it will collect the nectar. After collecting the nectar, it will make honey. With honey, it will make also the wax. With wax, you will make candle. And when the candle get burned, the parwana will come and they get burned and killed there. So you can see the interconnection, that link for that understanding for common man was missing. So don't write about your research in that way. For example, like as a journalist, I'm approaching you as a researcher. Can you tell me about your research, breakthrough of your research? So, but you said you wrote this equation on the board. Sir, this is my research. So, but I'll not be able to make any meaning out of that. Okay. So, until and unless you explain everything, my relation, my connect with that, or in such a way that it give a correlate, so that only I can make a meaning. It will generate an interest and sustain an interest of mine into reading that. Otherwise, it will not. So in the court of Bahadur Shah Jafar, where this Ghalib was there was another poet, Muhammad Taqi Mir Sahab, उनको we used to call him. वो बोलते थे, आपने कहा, I think, आपने कहा और आप ही समझे, like the scientist in the previous slide. आपने कहा और आप ही समझे तो क्या समझे, कहने का मजा तब है, means लिखने का मजा, like the joy of writing is become great when you are writing and the other one is also able to comprehend it or understand it. So share is like that. आपने कहा और आप ही समझे तो क्या समझे, कहने का मजा, मजा कहने का जब है जब एक कहे और दूसरा समझे. So the entire gist of popular science writing, popular science communication is given in this share. So you have to write in such a way that the other can be able to understand what you are intending to tell them. Okay. Oh, yeah, yeah. Can you just help me? I think okay. So now about the one of the few more objective or the concern about science communication was when we had a international conference on science communication in Delhi. So, and it was inaugurated by our beloved President Sahab, APJ Abdul Kalam Sahab. And he said, like, the purpose of science communication is like every citizen of the country should feel enthusiastic about science, and all people should be feel, you know, the concern about these climate change and global warming, and the sustainability of Earth. How to the sustainability of that need to be ensured, and and we should encourage the student to take up science as a career option, because this and but science communication is a bit complicated in the sense we are talking about the modern science. We are using Western terminology. Literature is also not available in our own languages. It is available in foreign languages. And the medium of education is also for us a foreign language. So these these sometimes creates a barrier in our mind. Okay. So popular science writing is like scientific writing is published, you know, the finding as a technical paper in a peer-reviewed journal like Science, Nature, or American Chemical Science, Omega, etc. But popular science, though we are writing it for publishing in newspaper, magazine, or blog, and for everyone, including scientists, as I told you in the beginning, and knowledge review, simple term, example with illustrations. So, but for technical thing, we use it is a new knowledge. We use a lot of technical term. We use a lot of figure, references, etc., which are not required when we do the popular science writing. No referencing is required in that. Okay, and we in journalism we use that a reverse pyramid approach in writing the article. Suppose the most important the lead is, say, the most important information about an event, W, who, what, where, when, why, and how, it has to be given in the beginning. Then the body, that the crucial information, expanding the topic, argument, controversy, etc., and the tail part. So lead, so whatever is your the breakthrough of your research, it should come in the beginning itself. Not try to build up the story first and then giving you the finding of your research, but it should come. But your construction of your sentences is such that the one can easily understand that, and the tail, the extra information interesting related to item, journalistic assessment about your own assessment, etc. And now this we take a clue from this. It says the basic of popular science writing is think in your mother tongue first, and you need to have a basic understanding of science. This is a, you can say, the advice by the famous Albert Einstein. And he said, if you want to take science to the people, first communicate it with your grandparents. This is possible if you yourself have a basic understanding of science. So that means, like, first we should be clear what are the basic science over which we are building as a part of our research. Okay, so I think we can skip to that. And the crafting of the title is very important, because most of the time when we are evaluating the story, we found, like, what is the title of your thesis has been given as a title for popular writing. It doesn't make any sense to the common man. So it should not be more than 20 words. Avoid listing potential application which are not feasible in the sense, and avoid acronyms, tends to have little meaning outside of a specific area. Means, like, the word plasma is different for a physicist and a life scientist. For them, it's different. So now let's take this case study. This was a research done in Germany in a lab, where they found that this spinach, that green leafy vegetable, has a steroid-like chemical which boosts the muscular strength. Okay, by eating that. So here the title, you can see how the writer has crafted the title. using the public memory, because you might have seen that a very famous cartoonistic character, Papaya. Huh? So he used to, get extra boost of power by using spinach through from a container, which you can see in the picture. So, and this research was done on this spinach, where they isolated an active compound, which they found is fall into the category of steroid. So that means any you're getting on the screen, any person, any athlete who is eating the spinach, palak kha raha hai, he is means like he's taking a band, he's taking a steroid which is present in that, and then that steroid should be listed in the prohibited list for athlete. So now imagine people who are vegetarian and athlete, so they will be barred from taking part into any international athletic event. So this was the first is the public memory in crafting the title, then coming the about the outcome and the implication, and also in between he has mentioned the methodology that this the active compound was isolated and experimented on these many people, and the result was that. Okay, they are not nowhere any technical terminology has been used in explaining that research, and it turned out to be a beautiful to for me it was one of the best article science story I have read ever, connecting to the people, having a connect utility, and also the writer of the story has giving his own opinion. And now you suppose if this research would have been done in India, we could have written about the Indian. You are muted. You're getting my voice? Okay, so now these are some of the examples, best story you can take it and think of developing your story. Okay, so I'm skipping that, and so Einstein again. I'm coming. If you can't explain it simply, that means you don't have understood it well enough. So here also you can make your story very interesting by adding those kind of illustration, because this was again about the coronavirus, which was in fact a flu virus, a seventh flu virus, which was most dangerous, even more dangerous to the SARS-1 also. So then in the second cartoon, we try to explain the difference between SARS-1 and SARS-2, because SARS-2 had an additional site of for replication, that was our throat, which was earlier SARS-1 was used to replicate only in the lung cells, but it found another active site of attachment and replication. So here, this difference has been explained through a cartoonist way. So where the SARS-2 is saying my cousin SARS-1 is bit dumb, but I'm smart. Because why I'm smart? Because I have a two site for replication in human body. So so this is like how a person could be a carrier. No symptoms has been shown on that. So this was again, these are some of the way you can do. So, so this all about my side to about understanding of science communication and how you can build up your story based on your research and your finding. So thank you very much. If there are any questions, I think we can take it up at a later stage. Thank you very much.
Thank you, sir, for providing deep insight to why and how science must be communicated effectively to the common man. I would now like to invite Dr. C.M. Nautal, sir, consultant in SA, for a talk on basics of science communication and its popularization.
सर स्क्रीन शेयर को ऑफ कर दीजिए.
So, shall I start?
Yes, sir. Yes, sir. You can start.
Okay. So, for about 40 minutes, right?
Yeah.
It's just the critical time between good morning and good afternoon. So, please take as you like. It's almost 12. We just heard Dr. Tyagi. He elaborated on certain aspects of science writing and very beautifully. And I'll be extending the same thing, but with a different angle. And so I'll right away start with my PPT. I'll share my screen. Here I go. Now I go to full screen. This is a new term which you may not find in any dictionary, writing science. This is by mixing write and write. Several of you must have been writing for magazines or newspapers or other publications. But there are two important things there. One is a science that we are writing correct? Second part is the way we are writing, is that also correct? If you're not writing it the right way, then the science that we are communicating to people may not be the right one, may not be exactly what we want to do. So therefore, we have to take a lot of care for that. But then the first thing is, why do we want to tell people about we or you belong to a specific category, a very privileged community in this world, people who have studied science up to maybe PhD, maybe up to master's degree. You are all pursuing or finish your PhDs. Therefore, you are a privileged class, but everyone in this world is not. But they must know a little bit about science. And as Isaac Asimov said, a public that does not understand how science works can all too easily fall prey to those ignoramuses who make fun of what they don't understand, or to the sloganeers who proclaim scientists to be the mercenary warriors of today, and who are just stooges of military. The difference between understanding and not understanding is also the difference whether they would respect science or they would hate it, taking it to be some kind of a warmonger or something. This is really very important that people must understand about science. So in this talk, we know that all of us who are here are not really completely professional science writers. Perhaps maybe one or two of you would turn into science writers or science communicators in due course, but majority of the people here would be professional scientists. So why do we want to learn about communicating science? I'll tell you one advantage is, of course, you will be communicating your science to the people, and which you will come across very often in your career. One is in understanding your own subject matter. The writing of your work will be very helpful to you. When you write it for the common man, you really understand the significance of your work. Preparation for your interaction is also very important. When you prepare for a fellowship or a project, or to give a lecture for some award or something, because most of the people sitting there are not experts in your field. So your job is to explain to them in simple language what you have achieved. If you are a good science communicator, you will be successful in doing that, and therefore the chances of winning that award or a fellowship or project are higher. When you talk for public, whether this is through print media, whether this is through newspaper or television, you are also fulfilling a social duty of yours, because our research has been supported by the taxpayers' money. Therefore, it's our duty to tell people whatever research we are doing. Similarly, sometimes you may come across that a paper is sent back to the author saying that please write it better, or get it written by a native English speaker or native English person. Or they may even sometimes say that your paper is too specialized and is not suitable for this journal. For example, if you write a letter, letter or short paper for nature or current science or science, then it has to address a wider audience than a specialized journal. So if you don't write it properly, some of these journals may not be willing to accept your papers when you submit them. Therefore, writing is an art, and all of us, whether we are professional scientists or we are science communicators, we must learn it. When we are talking to the common man, we have to use the common man's language. If you write water is at 9 kilometers, but if you write H2O is at 50 meters, you are confusing the people, because if water is available at 50 meters, people don't have to crawl 9 kilometers. So the communication is meaningful only if it's comprehensible to the target audience. But we should also understand that we will never be 100% successful in communicating what we want to. But if we are able to communicate 60%, 70% of what we are writing, I think it's a fairly successful thing, and we can believe that our job is well done. This interaction of mine, this talk of mine, will talk to you about what demands are made by the special nature of science. We will also understand how writing for peers and writing for the laypersons differ. Dr. Tyagi has explained some points to you. We'll discuss them further. What are the challenges that are posed in communicating science? What are the difficulties that we face, and how do we overcome them? One point which I will emphasize would be how to avoid ambiguity in writing. When we are writing science, we have to be very clear, and the message should be communicated very, very succinctly, but at the same time, very clearly. And what is it that we can write about? In short, I will tell about what cautions to take when we write science. Because science is something different, and the rest we will learn from experience. But then why science is different? Because in science, we are dealing with objects which are unfamiliar. Not many people may have come across them in their everyday life. Their shapes may be unusual. Look at the COVID-19 virus, for example, popularly known as coronavirus. This has a very strange shape. And since this resembled the corona, you know, is the coronation or the mukut of the sun. So it resembled those spikes coming out of its spherical protein-made body, made it look like corona, and therefore the name corona was given to this class of viruses. The dimensions in science can be unimaginable, either unimaginably small or they can be unimaginably big. Compare the size of the virus, which may be a few hundred angstroms, with the size of a galaxy, which may be tens of thousands of billion years. Here we are talking of things which you don't really see, only effects are seen. For example, electric field, magnetic field. You don't see anything acting on an object, but the object starts moving because it has got a charge, and this is inside an electric field. Or there can be a magnet, or there can be a magnetic material. It's inside a magnetic field and it moves. But this is attracted. A positive pole is or north pole is attracted towards the south. But you don't see anything which is acting on them. So these are abstract things, and explaining them sometimes can be very difficult. And another problem is, of course, that most of the scientific and technical knowledge is confined to the research journals. In India, we are publishing quite a few magazines, including one by AWSAR, Dream 2047. Now, magazines like this are there, but not many good scientists are writing for them. So I think a challenge before us is also how to encourage, how to inspire the practicing scientists to write on science for the common man, because a professional writer can do it, but his background in science is not strong enough, whereas scientists don't do it because it doesn't add to anything in their curriculum. So I think we should do this as a social. To start with, let us first think about the topic and title of your article. If the topic or the title is interesting, people would be attracted. If you write it like title of a thesis, I don't think many people will care to read that article. So the title of your article should be catchy, it should be understandable, but also written in a way that arouses curiosity. The format, whether it's an article, a poem, it can be in the form of even a drama, it can be a script for a television or whatever. But here in AWSAR, you are writing an article, and an article for people whose background in science may be just at high level, as Dr. Tagi just explained. We have to be very careful that we don't use too many technical terms. And the style should be very friendly to the reader. The content should be solid, but at the same time explained in a way that people with very little background in science will understand that. And there should always, at the end, be the gist of your article. What all you are going to say, as you have said in that article or written in the article, should be summarized at the end. That will make it easy. Similarly, there should be an introductory paragraph which gives why that work has some significance. In case of AWSAR, you'd be writing about your research, but your research may be in a highly super specialized field. You may be writing about some material which you have developed, which you have fabricated or synthesized or assembled in your laboratory, and a common man does not understand why it's important. So you have to give a background. What is the importance of developing such material? And since most of the time the research is incremental, you don't every day come out with quantum jumps in research. You have to give a background and then explain to people why your contribution adds to the knowledge and what are the possible scope in the future. But don't dwell too much upon that, because it should not look like promising much more than what really there is. So when we decide to write an article on based on our research, we should also worry about who our readers are going to be. I think it's practically impossible to write an article which will appeal to a 10-year-old child and also to somebody who is working in that field. So we have to be very clear about an audience. Decide on your audience. It doesn't have to be 100% readership of that magazine or newspaper. Decide on that and style your article according to that. You use a language which most of the people would understand, go by the least common denominator. You also decide what you are writing for. If you were writing for a magazine or a newspaper, the length of the article would be very different. Generally, in newspaper, it would be 500 words, usually. If it's an article, maybe 3,000 or 5,000 words. But when you are writing for AWSAR, you have been given a specific word length of around 2,500 words. So please respect the limit of the word, because that is also one criterion on which you would be evaluated. Then you should also understand very clearly what is the motivation behind your writing. Do you want to motivate people? Do you want to explain to them the significance of your research? Do you want them to understand the science involved in your research, technology involved in your research? So you should be clear about it before writing. Now, what should be the structure of the article? This is where most of us who are practicing scientists or professional scientists, we make mistakes. We think that just like in the thesis, where we have a synopsis first, then we have an index, we have an abstract or a synopsis, we have index, then we have introduction, then we have the background in the introduction, and then we go for next stages like our methodology, our observations, our analysis, and we go for the conclusions and also the. In case of an article writing for AWSAR, you don't have to follow that very formal structure. You can start your article with something which is very exciting outcome of your research. That arouses curiosity, and your reader is now interested in reading what you have written. Be thesis or research paper, the language is very formal. The style is quite more or less set, as I just explained. But for a popular science article, your style should be very friendly. You don't have to write in long, passive sentences like the experiment was performed with utmost care. and the care was taken that no chemical falls on the floor or whatever. All those things you don't have to write. You write in your active voice. For this, we prepared this solution, making X and Y, whatever that is. And then you also explain what that X and Y chemicals are. Your narration can be personal, but always keep in mind your readership. If you are talking or if you are writing for very young people, then your style should be very simple. You can have anecdotes. You can start with a story. Your language would be very simple because the vocabulary of the young audience or the young readers is very small. But if you are writing for people who have background in science, let's say they are all graduates in science, then the level can be different. But in case of AWSAR, please remember that you are supposed to be writing for the common person whose background in science is not very high. Is if you are talking about a new and difficult concept, please explain that. If you are using a technical term or if you are using mentioning some technical procedure, you can use a box kind of thing, and you can explain that in a box. How much of data or graph should be? In a popular article, this is almost a blasphemy to give huge tables or complicated graphs with the x-axis defining something, y-axis defining something, then 3 or 4 different colored graphs. Nobody would understand. Here, please remember your reader is not a scientist. So you should try to avoid graphics if possible. But if you have to give some graphics, in that case, please keep them very simple. The axis should be very clearly defined. If there are technical terms there, please explain to them in the caption of that graph. If you are showing a photograph, maybe a very complex photograph, but there may be a certain part which is of interest of the reader for that article. So please point out that. The Tyagi has also explained to you that generally the reader is not very much interested in the procedure. See, the procedure to a scientist is very dear because this is what takes usually most of the time. When you are generating data, you work day and night, generate a lot of data, and then you analyze that and write the conclusion. But a reader is generally not interested in the fine details of your experiment, unless that is what you are writing about. Suppose you have developed a new method for creating in the laboratory some new kind of material. In that case, it may be important that you had developed a new procedure and you want to write an article about that new procedure. In that case, it's fine. Please elaborate on that procedure. Otherwise, if it's a standard method, just give the outlines because person can always go and refer to the original article if he's interested, he or she is interested. But otherwise, you please don't go in the nitty-gritty of the procedures and simply mention that this procedure or this technique has been used for developing this method. But however, if you feel that that is the heart of the matter, then you can also give it as a box. You can also give it as a footnote and so on. Another important thing is when writing for the common people, you have to first make sure that after reading the first paragraph, the reader is interested in going on further. So you can start your article with some anecdote, with some story. You can also start with some cartoon characters if you find some similarity. Can you draw a cartoon or can you find a cartoon which can go with your article? If yes, please go ahead and use it. If you are writing for very young people, then you can splash your article with colors, with colorful drawings, and so on. You should also understand whether your readers are experts in the field or they are scientists by profession or they are not. But I can tell you one more thing. You are a specialist in one particular field. And even, for example, if you are a physicist and you are working in the material science, there are other people from nuclear physics who may not be able to understand the basic concepts in material science. You have to explain to them. Please treat your readers as the wise in your specialization and explain things to them so that they understand. You also grade your readers. You have either you have a whole spectrum of audience in your mind, from 10-year-old kid to somebody who has a PhD in any particular field of science. In that case, you have to explain everything to the basic. But if you decide that you are writing for somebody who has some background in science, then you use your content and language accordingly. No formulae, no equations. Stephen Hawking was told by the publisher that if you use one single formula or equation, the book's sale will go down to half. He was joking, Hawking was once joking, that I have used E equal to MC square in my book. And but for that, my book would have sold double as many copies. So we have to avoid using equations or formulae. But if you have to use some very simple equation or formula, please use, but explain the meaning. Don't assume that the reader would understand that. Another thing you have to keep in mind is that whatever you write will be read. When you are on a television, the audience or the viewers can see your expressions. But when you are writing, every image, every mental image has to be created with words. And this is an art not many people easily master. When you are describing something, look at it as a bystander, as an onlooker. You have been seeing that object or that instrument or that animal or that machine in your laboratory day in and day out. So you know that the knob is at the right-hand side, some other part is on the left-hand side, the flask is at the top, and the wheels are at the bottom. But the reader does not know. So either they show a photograph and give a good caption, or you explain it so well that reader can make a mental image of that object in the mind. Because when you are writing, you cannot gesticulate, you cannot raise your eyebrows, you cannot smile, you cannot move your eyes or pop your eyes, you cannot show your hands movement and tell them that this is very small or this is very. Therefore, when you are writing, please be visual, imagine the thing, and then you write. Another thing is when you are writing a procedure or something, you have to be very careful. Clarity is very important, particularly in technical instructions. I can tell you this with a joke, with this cartoon. Bannu was the best blacksmith in town, and then he engaged an apprentice by name Santu. Now, Bannu said to his apprentice Santu, strike with the hammer when I nod, or when I nod my head. And then he nodded his head, and Bannu hit with the hammer. Bannu was hit with the hammer by Santu, and now Santu is the best blacksmith in town. Because Bannu had forgotten to tell him very clearly that when I nod my head, please strike with your hammer the iron rod. And so Santu hit his head, which he nodded, with the hammer, and therefore Bannu died, and now Santu is the best blacksmith in the town. So, particularly when you are describing a technical procedure, you have to be very careful in wording, very careful, keep the sentences short. Don't use very long sentences. If you are using a demonstrative adjective or demonstrative pronoun or adjective, then please make sure the reader can very clearly get what it is qualifying. When we are writing about chemicals, that you mix two chemicals, or some particular compound is made with two atoms in a particular ratio. Now you see here, if you go to a shop or to a restaurant and you are attracted by its poster which says that we are selling pumpkin and grapes vegetable, kaddu and angur. Now, what do you guess from that? You will expect that you will get a good taste of grape also in the vegetable. When you eat it, you find that there is no taste of grape. Then you go and ask the shopkeeper, have you added any grapes in the vegetable? He said, yes, sir. We have used 1:1 ratio. Then you go back disappointed because now you cannot do anything. It's only later it will occur to you. When he said 1:1 ratio, did he mean 1 pumpkin and 1 grape? Or did he mean 1 kilogram of pumpkin and 1 kilogram of grapes? unless you clearly specify that a particular compound or chemical is made by the chemical reaction of two elements in atomic ratio of 1:1, or 1 gram mole of each element is taken, or 1 liter of each gas is taken at standard temperature and pressure, or 1 kilogram of each element is taken, the person who is going to repeat the experiment will not understand. This is something which is useful even in writing technical papers. And when you are writing for the common man, even there you have to be careful and define these things very clearly. Very often we are talking of things which are very huge. Very often we are talking about things which are very small. Even if you print a photograph, this doesn't give the reader an idea of how big that object is. The object which you see here at the top is actually a fraction of a millimeter in size. This is pollen of some plant, and this pollen may be 100 microns in size, which means 1/10 of a millimeter. If you print it big, the reader may get a wrong impression that this is huge in size, whereas a galaxy which is printed, whose picture is printed or whose photograph is printed, may look smaller on paper, but actually this is much more bigger, because even the biggest pollen grain may be a few hundred microns. A huge microfossil may be a few millimeters, but the smallest galaxy in the universe may be 200 light years, which means tens of thousands of billion kilometers. So your job is, when writing, that the reader should be able to create an image in the mind what the object looks like. And therefore, several things become important. Number one, what is the shape of that object? You have to describe that very clearly. For example, if you're describing coronavirus or COVID-19 virus, what would you say? You would say that this is very small in size, and this is, now if you say 300 angstroms, nobody would understand. Then you have to explain it in terms of thickness of the hair or human head. Human head hair is maybe 60 microns in thickness, maybe 100 microns in thickness, which is 1/10 of a millimeter. But a coronavirus is several hundred times smaller than that. If that is the way you will explain, perhaps they will get a better. Then you have to tell them about the shape. The shape is, in general, spherical, on which there are spikes protruding on the surface. These spikes are made of proteins, and this protein shell contains ribonucleic acid inside it. In case of corona, this is RNA. Otherwise, for a virus, it can be RNA or DNA, either of it. And then you have to explain that there is a lipid layer. Now, a common person will not understand lipid layer. So you have to say that this is an oily stuff which is coated on the protein shell. So if you explain to a common man like this, they will get a mental picture of that object, which they will not otherwise get. And then you can also print a photograph or a drawing, whichever is available there. If you print a photograph, perhaps it will not become that clear to the reader. So maybe you can include a diagram, because there things can be shown much more clear. Now, in case of AWSAR, what is it you are going to write about? There are thousands of topics in the world you can write about for your AWSAR article, but you are supposed to write about your own research work. It may be your PhD thesis. It may be one of your research papers. Now, in your article, how much is the introduction and how much is your actual research? There is no definite ratio that out of, let's say, 2,500 words, you have to write 1,250 articles for introduction, and the remaining half as your research. No, there is no such formula. You have to decide if you can explain the significance of your work to a common person using 1,000 words of introduction. Please use 1,000 words. 500 words are enough because the topic is common. Then please use 500 words. But if you think that the topic is so super specialized that you have to take 1500 words to first give an introduction or background to the article. It's fine. The ultimate purpose is to the reader, it should become clear what research you have done and what is its significance, and if it has got some potential applications. Don't presume too much on the part of the reader. We have been repeatedly saying, very often what happens is when you are talking to your peers, when you are talking to your colleagues or in a conference, their prior knowledge of the subjects helps them to understand what you are speaking or writing. But this is not the case when you're writing an article for AWSAR, because the reader may be a layman. When you simply say plug in power, switch on, wash with acid, or things like this, the specialist audience or readers understand. It's not always so. Sometimes science throws up surprising facts, and your reader will take what you are writing based on the notions in his or her own mind, and not according to what you are saying if you are not emphatic enough. So please remember that if what you are explaining very different from the established notion, then you should make it very clearly that when we are talking of this thing, we generally mean this, but here we don't mean that. When the subject is new, sometimes very small things will be critical and you have to explain to them because people may not be familiar with them. For example, if you are a physicist, if you are a plasma physicist, and you tell somebody that bring me some plasma. Now, what does that fellow bring? Plasma, as you know, is the fourth state of matter. For example, fire is plasma. This concept of plasma may be completely different. He may think that what you mean by plasma is the plasma present in our blood. So the plasma to a physicist means something different. A plasma to a biologist means something different. Whenever you are using a technical term, please explain that so that other person understands. Now, this means you have to have a very rich vocabulary. Language and words are very important. Shabda Shakti, power of words is tremendous. And I can give you one example that many of the Nobel laureates, if you read what they write, sometimes this is as beautiful as poetry. You read the writings of Medavar, you read the writings of C.V. Raman, you read the writings of Watson and Crick, and many such people, you read the writings of Feynman. These people used to write beautifully and they make the picture clear. And I think this may have to do with the clear thinking also. Therefore, if you are naturally good at it, maybe you would do it, but otherwise you have to make efforts. Use the right word. I'll give you a quote from Alice in the Wonderland. When I use a word, Humpty Dumpty said in rather a scornful tone, it means just what I choose it to mean, neither more nor less. The question is, said Alice, whether you can make words mean so many different things. The question is, said Humpty Dumpty, it is to be mastered, that's all. Humpty Dumpty is the egg sitting on the wall. So whether we can use a word properly, it's up to us. The same word can mean something different in a different context. So whenever you write something, please also give it to your younger people, your friends who are not specialists in the field, or even you can read it out to your mom, to your sister, to your brother, and then say whether they understand it. If they don't understand, then your article may not be fit as an AWSAR article, because for AWSAR, you have to write something which others will understand. And there is another problem which we face, that is of dangling modifiers. I'll give you a sentence as an example. After struggling for an hour, the veterinary doctor and the animal were face to face. This sentence doesn't make it clear who was struggling, doctor or the animal. In some situations, you can make out from your common sense, but it's not always possible. Therefore, if you're writing an article, it should become very clear. Please don't write sentences which are not clear. Similarly, after orbiting the moon for several days, the scientists decided to drop the probe on lunar surface. Who was orbiting? Was it the space probe or was it the scientists? Sentence does not make it clear. So whenever you write a sentence, particularly a long sentence, please make sure that this conveys exactly what you meant to. When you write an ancient carbon mystery, is it mystery of ancient carbon, or is it an ancient mystery about carbon? You know the difference between the two? In one case, carbon is ancient. In the other case, mystery is ancient. So the placement of adjective and the qualified noun or pronoun is also very important. As far as possible, the adjective should be close to what this is qualified. This is an example from a very big newspaper. Apologies to those who don't understand Hindi. The caption here is भवन की बिल्डिंग से कूदकर आत्महत्या करने के बाद पहुंचे लोग. Now, how can somebody who has committed suicide reach to watch or see his or her own body? You would see that whenever somebody is writing in hurry, as it happens to the man at the desk who write the caption for the photographs or news, they sometimes make these mistakes. So the meaning can completely change. Now, in this case, our common sense tells us, and we can extract the correct meaning from this sentence. But if it were in science, where nothing is known to the reader is free to make his own conclusion. That can mean disaster. We have to be very careful. Comma is also very important. For example, a woman without her man is nothing. Here, women will be very happy. Second is, a woman without her man is nothing. A woman without her man is nothing. So I'm sorry, the man will be very happy. And if you write a woman without her man is nothing, the women will be very. So just placement of a comma changes it. Similarly, एसिड को टेस्ट्यूम में बीकर में जाने से रोको. Stop the acid from going to the test tube, comma, don't allow it to go, otherwise there can be an explosion. This is one sentence, which means if you want to avoid explosion, stop the acid from entering the test tube. This has one meaning. You change the position of the comma, make it अम्ल एसिड को टेस्ट ट्यूब में से बीकर में जाने से रोको मत, जाने दो, नहीं तो भयानक एक्सप्लोजन हो सकता है. The meaning is just opposite. Now, what should the poor reader do who is reading this technical manual and the writer has not been careful enough? So even the placement of comma is very important. As for terminology, if you are writing in English language, you will have to use the technical terms. Please use them, but if it's an uncommon thing, define it. You define the term, the exact meaning of the term. If you are writing in a regional language or in Hindi, then you can use the standard terminology given in the CS3TT publication, Commission on Scientific and Technical Terminology. But if you feel that the term may not be comprehensible to the reader, then do use it by all means, but also explain its meaning to the reader by defining it, by explaining it in a simple manner. Look at these sentences. We can see red and also green bulbs here, whose switching off eliminates the possibility of explosion. When you write whose, the reader may be in confusion whether this whose refers to red or green or both. So you should be very careful in writing sentences like this. I think I don't have much time left, so I'll just go to some other things like 100% pollution free or 100% pollution free. The meaning of the two are different. In the first case, 100% pollution free means you don't have to pay, you will get pollution without paying anything. In the second one, 100% pollution free. This is completely free from pollution. When you use a simile For example, those who are from physics would know about the plasma is usually confined in a toroidal shape inside a fusion reactor. Now, how do you describe a toroid to a lay person? He may not understand the term toroid. You say that this is like a vada. You say this is like an inflated tube of a car, which is inside the tire, and so on. But if you use the original term toroid, not many people might understand. And if you use the term donut, even that many people will not understand. So please try to find simile from the vocabulary which is familiar to your readers. When you give similes to compare two things, your idea is the reader compares it with the known object, so he gets a fairly good idea about the shape or property is like. But if you're not careful, suppose you say this object or this item which we see is like a football. Reader would be confused. Is it round like a football? Is it made of synthetic material or leather like a football? Is it inflated with air like a football? Is this an item which is used for playing in the playground? Or is it something which is bouncy? So unless you clearly state in which respect the similarity is suggested, the reader will not be able to make head and tail of it. Therefore, whenever you give a simile, whenever you give an example, please also mention the attribute in respect of which the similarity is. Now, you can try to have some element of humor in your article. You can include the cartoon. For example, here I drew this cartoon for some publication on COVID-19 poetry book. Here there is this famous jinn of Aladdin. And what he's saying, Maafi mere aaka, mask nahi, duri nahi, हाथ भी न धोना और मैं कोविड से बचा भी लूं, नामुमकिन, here I go. Sorry boss, no mask, no hand washing, no distancing either. And you want me to save you from COVID-19? No way, I quit. By inserting some cartoons, some pictures, some interesting diagrams, avoiding equations, avoiding complex graphics, and so on, you can make the article easier to understand. Use language which is attractive. Don't forget to give some examples from the current world. If your topic refers to something recent, refer to it and explain it in the context. And then I think you'd be able to explain your science to people better. Do use the standard terms if essential, but please explain to them. Do not glorify the science or the scientists too much. I mean, people say that Newton was sitting under the apple tree and he got an idea of gravitation theory. That is wrong. As scientists, we know that whatever we say, whatever we do is a result of a very, very long thing. So please don't glorify it, that we give a completely incorrect picture to an entrant in the field. Similarly, you know the example of Kekule's finding of the structure of benzene. And people say that he was just dozing off and he got that idea. So we have to be careful. Use the simple language. Miocene domain evolution and primary divergence in eukaryotes. This was the original article of an article in an article in Nature. But how they gave it in the first few pages and the news, they called it evolution, a treasure trove of much easier to understand. So even nature ordains simplicity. Similarly, there was another title, crystal structure of a bacterial homologue of Na plus Cl minus and dependent neurotransmitter transporters. Not easy to understand for a common person. And you simply say molecular physiology. Intimate contact enables. So this shows that even technical journals care for it. When you are writing for the common man in AWSAR, you should be extra careful and write in a very simple language. Now, look at this example. You have seen a newspaper clipping shown by Dr. Tyagi just now, where there was a mention of methane detected on Mars. The rover, which was on the surface of Mars, detected methane. But you may also be knowing that methane has also been detected. 10 ppb methane has been detected in Martian atmosphere by an Earth-based telescope. So if your title simply says methane detected on Mars, it may not look something very new because it has been detected several years ago by Earth-based telescope. If you say life on Mars, just a second, please. Hello. हाँ, अब 5 मिनट में कॉल कर 5 मिनट में मैं आपको कॉल कर so if you say life on Mars, this is confusing because methane is released as a bioactivity from our bodies and living things, or even bacteria. Sometimes bacteria also give away methane, but that does not mean necessarily life, because methane can also have inorganic origin. It can be coming from the interior of Mars. So life on Mars is a misleading title. Similarly, methane, indicator of bioactivity found on Mars, or an indicator of bioactivity found on Mars. This is a slightly better. And people can sometimes jump to the wagon and say Mars on life detected. This is wrong. Finding methane on Mars does not mean that life has been detected. This is one indicator of life, but is not enough. Similarly, methane observed in Martian atmosphere by Earth-based telescope or by rover on the Martian surface. That is a more correct statement. So our claim should not exceed the actual. Then I'll give you just one more example. How, for example, I was working in the radiocarbon dating laboratory. So if I am explaining it to somebody who has good background in science and mathematics or in radioactivity, I would tell them about radiocarbon age or radiocarbon dating using a graph. But if they know about mathematics, I can even give them the equation that age of a material in which radiocarbon has been measured can be given by T equal to a log of A naught, where A naught is initial activity, minus log of A, where A is the present activity, and this has divided by lambda, which is the decay constant. This will not be understandable to many people unless they have background in science. So is the next level I go down, I show them this graph and show that the amount of radiocarbon present in a sample decays exponentially and goes on decreasing, and after about 7 or 8 half-lives, it becomes almost zero. If my readership doesn't have even this much background in science, I will explain to them in a simple method. I will say, if there are 16 atoms of radiocarbon, after one half-life, half of them will decay. After another half-life, half of the remaining will decay. This is like if you have green mangoes, half of them ripen after 1 day, half of the green ones again ripen after another day, and so on. So if we are given a mix of ripened or ripe mangoes and raw mangoes, by their ratio, we can find out how many days have passed. These are some of the things which you have to develop on your own if you want to explain science. Now, you have many options, but in case of course, AWSAR, you have to write an article. And in communication, you should also remember that even if you are communicating science, a human being is a mix of logic and sentiments and emotions. If you can touch the heart of the person, your message will be communicated more clearly. When you send I love you message to somebody, you don't send them the actual diagram or actual picture of the heart with all of these ventricles or arteries and so on. You simply sell them this red-shaped heart. Please always remember, the article will be very successful as far as communication is concerned if this is written with sentiments as well as brains and logic. Thank you very much for listening to me. Thanks.
Thank you, sir, for fostering the scientific temperament in our participants. Joining now is Dr. Kollagal Sharma, sir, ex-chief scientist, CSIR, to deliver a lecture on fundamental of science writing and journalism.
Thank you for the brief introduction, but can I have the sharing, please? Hello, am I audible?
Yes, sir.
Yes, sir. Yes, sir.
Okay, so it's always a pleasure to speak after Dr. Tyagi and Dr. Nautiyal, because they will cover almost everything and making my task much easier. So today I will not be speaking about why science communication is important for us, because that has been extensively discussed and explained by Dr. Tyagi, or how we should be writing for a AWSAR as scientists, mainly because that has been covered by Dr. Nautiyal. I would just be taking a few examples from the published AWSAR essays and briefing how we could improve them, or what we should be doing as scientists. My title is Science Writing is Equal to Translation. This is because I always consider science or the scientific text as a different language. It's not English. The English that we speak is the common language, whereas the English that we use with our peer groups in the scientific world is a different language. And how is that language? How different is that language? Briefly, Dr. Nautiyal has given some features of this. So I'll be just illustrating with examples here. Okay, this is not my idea that the science is a language, is a separate language. In fact, Shakespeare also said that for him, he says that the rose is the common English language, whereas the dicotyledon is what the scientists look at rose as. And this is how the difference between the two cultures mentioned by Dr. Tyagi is there. The two cultures, the scientific culture as well as our common culture. Although we live in both of them, when we start conversing, or when we start telling about our scientific exploits or experiments, we tend to use generally the language of science rather than the common language, and that's a problem. And the other thing is, like Dr. Nautiyal said, we speak on things or about things which we cannot see, we cannot touch, we cannot feel or anything. So most of the scientific issues that we discuss are beyond the experience of our common people, and therefore how do we bring them into the commons experience is the question that we say. And in fact, there is a common belief that the most of the science that we talk about is spoken in metaphors, in the sense that we talk about the principle, the happenings in science as if they are happening in our life. Okay, but the meaning of which will be slightly different. I can give you examples of that. I would have used the example of vada here, but already Dr. Nautiyal has used that. So event horizon are the black hole, chromosome, gene, gravity. All these words have come from roots which are very common in use. Gravity, for example, is from the root which says that something is heavy. So the concept of a body with a mass attracting another body with another mass is something that is related to heaviness, and that is how the gravity has come. Similarly, gene, that which is born out of something, or a chromosome, a colored thread, and a black hole or event. So these common words were actually designed to explain something that we saw beyond our sense, we felt beyond our senses through something that we could sense. So a chromosome which we cannot see normally, but under the microscope was seen as a stained thread or colored thread, and it was named chromosome. So this kind of metaphorical expression or metaphorical explanation of scientific phenomena is what makes the language of science different from the common language. And there is something like this. Generally, the features of scientific text that we usually do write is passive, whereas what we use in our day-to-day conversation have active voice. So the passive voice and active voice is very simple. You can see here, the purpose of this work was to study the effect of different frying process on some physical and sensory properties of potato chips and to evaluate frying oil quality. So use of this passive voice is what makes science, sound strange. So can we change this into active voices? If we change the same thing into active voice, it sounds much familiar. And even if we use a little bit of the same type of technical words, this appeal will be much better. So for example, here, the same thing, we wanted to test or see how different frying methods could change the taste and texture of potato chips, and if this could be a test or measure of oil quality. And that's what the experiment was all about. So it wanted to see if the texture and the taste or the sensory qualities of the potato chips fried in an oil can indicate the type of oil or the quality of the oil. And this is something that we should be doing. So one of the important things that we need to do when we start writing for common people is to tell them in as far as possible in active voices. And if we are writing in Hindi or Kannada or Telugu or this one, these languages use invariably active voices, and therefore if we are using a passive voice in these languages as we do in the scientific text, they sound very strange, they sound different, and therefore readability or the attraction to the reader or the listener will be very less. Okay. And similarly, the other features of this has already been explained with ample examples by Dr. Nautiyal. The graphics is another important part of the scientific language. And wherever the graphics are there, it is easier for the peer group to understand what we are talking about. Whereas if we are talking of the same thing to a commoner, then we need to go an extra length, an extra step further, and try to explain what this means. So here we see the number of daily cases and deaths in the US with regard to COVID and how it changed over a period of 1 year. And the picture clearly gives the in the initial stages the deaths were more, and then later as the year passed on, although number of cases were high, the number of deaths were less. So what does it indicate is the question of analysis. But then this has to be made clear to them, the difference between the two graphs, and that's what generally we expect in a essay along with a graph. Okay, and if you simply give a graph and say that please see a graph, that will not be enough in a popular science article. Then again, the abbreviations or the acronyms are another bane of scientific literature. Whichever research paper you take, there will be a lot of abbreviations, but we can see two distinct type of abbreviations. Here you see there is an NUO and a DFUO. I am referring to the same paper which was talking about the frying oil, and here NUO is the mice fed with new edible oil, and DFUO is the deep fried edible oil. So as you read through the text here, the reading gets affected because of the abbreviations. So instead, if you could use something like this, okay, as expected, mice fed with fresh oil weighed the most, and mice fed with deep fried oil weighed the least among the three groups tested. Okay, here again, as Dr. Navatyal said, what is the most and what is the least, you can explain in the next sentence, because that is only a relative measure that we are talking about. But when compared to the previous sentence and to this, it is much simplified, factually correct, but easy to read and easy to understand. So popular science writing generally expects us to modify the sentences, the scientific text to a common language like this. Secondly, when we talk about acronyms, there are two types. One is sorry. There are two types. One is the universal type, or what I call as global. The other one is transitory or temporary abbreviations. Some authors use for some words like the deep fried, edible oil, an abbreviation like DFUO throughout their text. But this DFUO is not a universal abbreviation, because in any other paper which also refers to a deep fried edible oil, DFUO may not be used. However, if somebody is using deoxyribonucleic acid and DNA as a acronym for deoxyribonucleic acid, there is always a high possibility that DNA that you find in another text will also refer to that. So these are universal. So DNA is used by most of the people to refer to deoxyribonucleic acid, but DFUO may not be used by others as an abbreviation. So therefore, there are two types, and when you use abbreviations, use only those which are universal. Avoid creating abbreviations in popular science texts as far as possible. And many times that is not necessary also. Of course, formulas are important in science. And here is a formula which is about a mathematical model that explains, or that is used to calculate or analyze the conservation happening in a forest area. And if that is the case, these formulae need not be included in the popular science articles. Dr. Navatyala has already explained that, and same with Dr. Tyagi also explained the same thing. So, but then it has to be explained. It has to be explained in a simple way, so that the relations between the different terms used here are clear. Please remember that every formula is not a calculation. Yes, they do use, are used for calculations, but formulae are not for calculations. They explain relations between different things that we are talking about. So if there are only 2 or 3 terms whose relations we are speaking about, they can be explained in a sentence like this. But if there are much more complex things, then you have to give only the gist of the ultimate relation that you expect here. And that's how the thing is. So I would like to write about this formula, saying that it can be calculated of how many plants are expected to survive at the year end with the current funding, and given a specific inflation rate. Similarly, we have several other features in scientific texts. Some of these are listed here. We use a lot of terms together, joined together, and put them as a single noun, and that's called interlocking. And we also have other terms here, when algae derived, jet noise. So these kind of words, when we use, it is easier because when we speak to the peer groups, it becomes easier for them to understand. Whereas for the commoners, the assumptions behind these technical terms have to be explained. Similarly, there are technical talk about the weather phenomenon. Sometimes we say that it is moderate or moderately strong, strong or extremely strong. So these have definite definitions in meteorological terms. Whereas for us commoners, that will be totally different. A moderate may be very severe in case of someone, or a moderately strong may not even mean anything for a person in you know, in Goa or the coastal region where the rain is usually heavy. Okay, so these kind of technical taxonomies have to be understood by us before we talk about those things. There are special expressions sometimes used: genomics, omics, proteomics, and how do we use them? Should we use them or should we avoid them, or should we explain them? Is something that one needs to decide depending upon the context. Okay, most of the time we can avoid these things because these are new terms which are used generally among only the peer groups, and they may not be needed. And there are some terms like Euler equations or Navier-Stokes or things which need to be explained clearly because some knowledge is needed to understand these kind of terms. Then there are background assumptions in several cases, and those assumptions also have to be made clear. And when you write something, you may be knowing that we are talking about this only to the peer group, and peer group can understand why you are talking, using that particular term, but for a commoner it has to be explained. So these are some of the other things that we have. And then another thing about science is that we create new terms every day. And this is very important because when we write a technical literature, a technical write-up, we may use a new term regularly, but it is not necessary that every new term need to be used in a popular science article. There are a few critical terms which we need to use, technical terms, but for most part we can avoid using the technical terms and still convey the concept of science or the phenomenon that we are trying to explain, or describe a tool that we are using in the science and technical world. Some of the words that I have here have come recently in after 2000, in the last 20 years, and before that they were not there, but we were still doing similar kind of research. So we need to understand, and it is not just the scientists who create these words. There's an estimate to say that from 200 to 600 words are created every year, every day in the scientific world, but most of them go out of use because many people don't even know about that. Okay, and some words are also created like this, but they become useful or used regularly, like brunch, which we use every day, the breakfast and lunch together, or the prostitute, which is in in the news, among the newsroom recently. The technical words and jargons are something that is we are very fond of, and we try to use them. We think that technical words are absolutely necessary. Yes, sometimes yes, technical words are absolutely necessary, but when we use them, we have to take care that to explain them at least once in the popular science article. I'm just putting here a paragraph that was taken from one of the AWSAR stories which got a prize. A beautifully narrated story, but again, while we narrate, we tend to forget a few basic things. In this particular paragraph, suddenly the author introduces a word called synapse and microtubule, the dense actin, Okay. Now, whereas these words are also used as metaphorically or compared with the similes like bushes, road repairs, and all. It could have been much better used. It's the microtubule repairs going on, or actin bushes, without using the parenthesis. The parenthesis sometimes affect your readability. So the reader might miss these words and still go on reading. Okay, it doesn't serve the purpose of writing then. So therefore, when we write, as far as possible, avoid parentheses unless you're explaining something there. So parentheses like this in a regular write-up will always be missed by the reader, and that is not the purpose of our writing. We want the reader to read every word that we write, and if that has to happen, some of these things have to be remembered. And when you introduce a word, please explain when you introduce a new word for the first time to the reader. And like Tyagiji said, we have to have a norm or a common norm that is the lowest you know norm for a language, and beyond that, if you are using any word, that has to be explained. Repetitions is something else that usually we find in a lot of texts. The same word repeated several times. If it is a synapse, yes, you have no other chance. But if you have used synapse and explained it as a joint between nouns, then you can always go and use synonyms like the nerve joints, or the meeting place of nouns, or whatever you want, and go like that. So that creates a lot of interest in this. In this particular paragraph, the author has used struck, stuck, and stuck several times. As you read through, what happens is that this repetition will be jarring, and therefore, wherever possible, if you can find synonyms for these things, use. The author has later used synonyms for struck at some other places. That is fantastic, but again, it is very much necessary that we need to also update our vocabulary when we look at the different words, whether technical or non-technical. Okay. Text flow is another thing that we need to look at. Generally, in the AWSAR essays that I have found, or we have noticed, is that what we have noticed is that people start with an enthusiasm. The first paragraph is fantastically written, and the story goes to the next paragraph. And when we come to the third paragraph, where some technical terms, some technical phenomenon has to be explained, all of a sudden there is a change from the common English to science. The technical terms, the passive sentences return here, and that sudden change happens unconsciously for most of us. So please keep a watch when you want to explain something that is technical. Are we writing in a technical way, or we are keeping all those principles that Dr. Nautiyal said, about the target audience, about simplicity of the language, about using a simile from our own examples, and other examples. So if we do this, then it will be easier. Okay. Otherwise, suddenly introducing such long sentences, changing tag into a technical mode will always be not good, or it will not give the expected results, and the flow of the write-up will also be different. Okay. Now the title, Nautiyalji has already explained how a title should be. As far as possible, shorter titles, simpler titles will always be attractive. And these are some of the titles that I found. And then punctuation. Look at this title. Now, what does it say? Is it asking a question or an exclamation? Just changing the the interrogation to a exclamation mark would be would give a different meaning to the same sentence. So we have to be very careful about what we write and the punctuations that we use. I have given a simpler version of this that may not be true and that may not be correct also, but if we can reduce the length of the title as far as possible, that will be very good. 20 words is what Dr. Nautiyal suggested. And if we can go further, lessen it to 10, that will be much, much better. Again, what is storytelling? In AWSAR, we usually speak of science writing as a storytelling. The storytelling doesn't mean that I did this, I did that. And that is not storytelling. Storytelling is stringing together your thoughts in an interesting way, where you also get the reader involved. And if that can happen, like Dr. Nautiyal said, the heart and the logic can go together, then that will be fine. In this particular example, an unnecessary anecdote has been included here. And even if we remove that, the story it doesn't get affected, and it is not necessary also. So simply saying that I did this or I did that will not make the write up a good story. So that's something that we need to keep in mind. Secondly, when we talk about these stories and all, the way that we put it across, it's not the style, but the way we put it across is also important. Okay, now here, since we were sure of osteocalcin and beta 42 association, we were curious whether these conferred any protection, is the sentence. Now, if we want to do a story, if we are doing a story, we can also write it this way. Sure, osteocalcin and beta 42 were involved, but did they provide in protection? No, we are asking the same question. We are asking the same message, passing on the same message here. But when we change the writing to a style like this, what happens is that the reader gets involved. He gets involved because you're posing a question, and the question makes him start thinking. And this kind of involvement is subtle little changes in the write-up can always make the storytelling much, much better. And we have found in AWSAR several cases, the paragraphs are not separated. The paragraphs play a very important role in storytelling because each paragraph, when we shift from one paragraph to another paragraph, we also shift from one line of thought to another line of thought. And therefore, that is the linking that we need to look at. And therefore, paragraphs must be are also important in a story. Please don't write all the 1,500 words in one single paragraph. Style is something that we need to give a personalized look to all the writings. Here, the writer starts with Ladla betas and betis, and then goes to explain that. So if you are looking at English, the Hindi and English audience here, we could have stopped at Ladla Bedis and Betis. That would have been one of the things. So don't first decide whether you want to do English, pure English, or you want to go for English. Then stick to that. Then secondly, analogies and similes. A beautiful example here is the swats that he is talking about, and he gives a simile of a boxing champion Vijendra, who is very, from it's a local example rather than Muhammad Ali in a distant place. So similes need to be local. Examples need to be local to attract the audience. I would stop here mainly because almost everything that one needs to know about science communication and science writing have been elaborately explained by Dr. Tyagi and Dr. Nautiyal. Repeating the same thing will not be appropriate at this moment. I gave some examples of how we can improve on the write-ups that we have already on the AWSAR this one. So my suggestion is, when you start writing, a storytelling is not telling your story. A storytelling is telling what you know in a very interesting way, so that every lead or every point that you are making is understood by your reader very well. And if he has to do that, then you have to catch his attention, and that is where the storytelling comes. Every paragraph should lead to the next paragraph and subsequent to paragraph, and finally give the gist of what you are telling. And this is what I wanted to say about the AWSAR stories. And I wish everyone good luck. If there are any questions, we can always answer here. Thank you very much.
Thank you, sir, for sharing knowledge of how to communicate science in the impactful way by taking care of technicalities in the write-up. Now, I would like to welcome Dr. Gaurav, sir, to provide us an overview of the AWSAR program.
Thank you, Vima. Am I audible?
Yes.
Yes,
Okay.
Gaurav, you're audible.
Yes. I'll share the website. Yeah, welcome all. This is the AWSAR website. You can note down the URL for the website. As you already registered for the webinar, you must be knowing it is awsar-gst.in. I will show you the process of submitting your story. So in the website, you will find all the criteria, guidelines of how to write your story. You will find some sample stories also. These are the selection criterias. These are the guidelines, how to write your story. What are the maximum and minimum number limit. So to submit your story, first you need to log in. And here is the login page. Yeah, I have created one demo link. So I will sign up with demo link. Okay, once you sign in with your credentials, you will find these two links. One is for website webinar registration, and one is for story submission. Currently, this link is not open as we have not announced the submission. Once the story submission is announced, this link will be there after you log in. Just click here. It will ask, have you earlier submitted your story? If you say yes, then it will ask for the reference number and the title of your story. And it will also ask if your story is awarded. If it is awarded, then you are not eligible for applying for AWSAR this time. If you say no, then only you can enter in your story submission. So let me put it no and click on submit your story. So this is the detailed form which you will find. So here are the personal details. You need to enter these personal details. We are also asking for Aadhaar card, your Aadhaar number, and a copy of your Aadhaar. You need to upload it from here. Then your basic qualifications, your PhD details, and this is your supervisor guide details.
What is the question?
Good afternoon, sir. I have already submitted my story. Yes. Before.
Hello, am I audible?
Can I submit a new story?
Yes.
Yeah, this is the most important part. Submit your manuscript.
Submit.
Here you will enter the category of your story,
even same
your
story with the
title,
you can do that.
some keywords, and your language. Now, in this part, you need to attach your story in Microsoft Word format, and that should be in docs file format. So if we select and submit a story with words of 1800 words, so our system will show a error that your story will not be submitted. Your document have 854 words. You can upload only minimum 1000 words and maximum 1500 words. Okay.
Maximum 1500 है या 2500 है?
No, sir. Maximum 1500 words.
1500. Okay.
1000 to 1500 words.
Agree.
So this file also has 1533 words. So it will show an error. So your short story must be in between 1000 and 1500 words. So once you upload your story, you can save your data, but that doesn't mean it is submitted. You have to preview and submit your story. Once you submit your story, you are not able to modify it. So please remember, you can save your data as many times as you want, but once you submit, you are not able to modify it. So this is the form. If there is any query related to submission, you can ask.
I think my advice to all participant is like you do the final submission towards the when this window is being closed, because once you like first draft, second draft, when you read yourself, you realize that there is a many much more scope for the improvement. So try to give your story for reading to your grandparents, to your parents, friends, brother, sister, and take their input about the understanding part and the how interesting it is that, and based on that feedback, you keep on revising it and uploading it, and only the submission you do at the end, that will be better. So at least my the advice to all of you is minimum 3 to 4 times. I think you revise, you first you read yourself, you will find a lot of things which you think is to be changed or has to be modified. Then give it, share it with your with your peers group. No, they cannot give you a better input, but give to common people, your friends who are not from the science background, and then to what extent they have understood about your research. So based on their feedback, you try to revise it, and that's why we are trying to give you a long time for the revision. Earlier experience is that like the window period was short, so most of our participants were not finding enough time to revise the story. But this time the time duration is very long, and you have many opportunities of sharing it with the other people, and keep on revising that. Yeah. Yes. So any other question about the story submission? And there is a one question, they said, like, if you are not the awardee of the previous AWSAR program, so you are eligible for that. It's only like the once you are got any award, whether first, second, third, or among the 100 your story has been submitted, then you are not eligible for the competition part. Okay, for the award part. But if you have submitted earlier but it could not make into the merit, you are eligible for that, so you can submit your story. And one more question was about this the author's personal story, and the giving example of this papaya. The to make story more interesting, using the public memory, that character which was very popular once upon a time, but still very fresh in the mind of people. So that was the best example. Suppose you are telling about an active compound as a research which has been isolated from that plant, that is a spinach, which has or which can fall into the category of steroid. So this is the finding. And now what are the things which are attached with the steroid? You can those has been explained. So any format for your story, you can choose that. Dialogic form is used more commonly, but I don't suggest that it is fit or it is a most appropriate for every story. So what Dr. Notial and colleague Alji has discussed you, it can be a narrative also in first person or third person. The story which are generally covered from the lab by journalists is done in third person. So it is up to you how comfortable you are in first person or third person. It depends on the content and your comfortability in narrating the story. So these were the two questions which I thought I should reply, which come from few of our participants. So if there is any other question, Vyoma, which need to
There
be
is one more
replied.
question. How will we add cartoons or design in our stories?
Cartoon you can, but cartoon should be such again of which can appeal the common sentiments or the common people, not very highly technical. Because I also gave a cartoon in my presentation where the scientist is explaining about his breakthrough to the journalist. So this was from the communication angle, but I have shown these some cartoon to like on Corona. So those kind of thing you can create your own character, your own things about that, a caricature to explain that. And I just like to inform our next webinar, we will be most probably we will be inviting Dr. Pradeep Srivastav, one of the world famous science journalist. So he will explain how from the basic science you can develop your own cartoon, and that can be part of your story. So if all of you are interested in that, I think you can join over the next webinar, which will be more specific on science too and science communication. Science communication
Sure.
through science too. Yeah. Colleague, you want to
Sure.
say something? Yeah. Mike.
Sir, you are not audible.
Sir, Mike.
No, you are unmute, but you are not audible. No, sir, no.
Am I audible now?
Yes.
Yes, sir. Yes, sir.
Okay. When it comes to illustrations with any article, there are three purposes for which we use illustration. One is just to give a relief in the text, and that is where you can simply use any illustration. Okay. And second thing is that kind of illustrations you will find in most of the newspapers. The second one is where a difficult concept cannot be explained in the text very clearly, then you add a illustration to that. So, the line drawings or the cartoon type of illustrations where, say, for example, the solar system that goes around. So this is something that we add to give the clarity to the thought, because certain things cannot be visualized, and things that cannot be visualized will be illustrated as a picture or a drawing. And the third type, of course, is a lot of data is there which you cannot present in the text, and you present it as a graphic text like a graph or other things. And this is the third type. And the last one is to bring some sort of a humor into the story, where you use the cartoons. So the cartoons or animated type of illustrations are some of the examples of this. So you have to decide what type of illustrations are needed in your text. If you have a lot of data which you cannot talk about in your text, then you need to have a graphic. And if you have something like, for example, the interaction of antibody with the antigen, or the structure of coronavirus which you need to tell about the people. So you can always explain coronavirus as sort of a, it looks like the datura, fruit or something like that. But even if, to be more precise, you need to have an illustration there. So these are the 4 types of illustrations that you can always think of. It is not that AWSAR always looks for cartoons, or you need to always use cartoons. It is you can also write an article without any illustration, but it can still be award worthy. The only thing is, how best can you communicate all the information that you have with the various types of media is what you have to think of. Thank you.
So I think or now, yeah.
AWSAR would like to thank all the respected speakers and the participants. Looking forward for your participation in our next upcoming webinar. Thank you.